Hi everybody, it's Leanne. I'm going to go through class activity 83, which is our last class activity for chapter 4. Way to go everybody. Hope everybody is doing well, staying safe, staying home, and feeling well. So this class activity I feel like is a lot of review of things that we've talked about. So it should go fairly quickly. Make sure that you reach out to your instructors if you're still confused about this topic, the standard algorithm for multiplication and why it works and all the various ways that we can connect these different representations. It's a pretty important concept. So here we go. All right, so to start with, in the first part of the class activity, we have an array that has 6 rows of 38 dots. I didn't want to draw all those dots, so instead I took the 38 dots and I separated it into 30 and 8 and made a rectangular array to represent this. So this would be my 6 rows, and then I have 30 columns of those 6, and then I have 8 columns of those 6 here. And the reason that I chose to do that, I don't know if that's the best color to use here. The reason I chose to do that is so that I can divide up my rectangular array to show, 30 groups of 6 or 6 groups of 30 here, and 8 groups of 6 or 6 groups of 8 here. And I want to make sure that we connect, in questions 2 and 3, we're connecting all of these different parts. So what we're doing is we're looking at 6 times 38 with the distributive property. Then we're going to look at 6 times 38, identifying the partial products, making some connections here to this visual representation or this array, and then we'll also do the same with the standard algorithm. Okay, so if we're going to look at the distributive property with 6 times 38, then what we want to do is look at, back to the meaning of multiplication, we have 6 groups of 38 or 6 groups of 30 plus 8. And if we have 6 groups of 30 plus 8, then we have 6 groups of 30 plus 6 groups of 8. So then we end up with these two partial products, 180 and 48, for a grand total sum of 228. So if you look over here, our 180 is going to show up in this section because we looked at 6 groups of 30, which is the same as 30 groups of 6. And our 6 groups of 8 is showing up here. There's our 48, because 8 groups of 6 is the same as 6 groups of 8. Now let's look at our partial product multiplication. This is going to feel really redundant because of what we just did here. So when we do partial product multiplication, essentially what we're doing is multiplying all of the numbers by each other, taking into consideration their place value. So in this case we say 6 times 8, because those are both in the ones place, so it is 6 times 8. And then here we're going to multiply the 3 times the 6, except we're not going to think of it as a 3, we're thinking of it as its place value, which is 30 times 6. And in this case, we only have 2 partial products, so we sum those for our product in the problem. When we do the standard algorithm, we're going to essentially combine these 2 steps in one. And so what we do with the standard algorithm, of course, is multiply 6 times 8. We get 48. We carry that 4. What we're going to do now is the second part of the partial product, and we're going to multiply 30 times 6, except we think of this as a 3, not a 30. 6 times 3 is 18, plus 4 is 22. And by doing that, we've combined these 2 partial products into one step, which is why it is our algorithm, a procedure that works sort of a shortcut, more efficient way. Let's look at it with some different numbers. And this is question 4, 5. What is this? 4, 5, 6, and 7. And so I figured you could do 8 based on all of this on your own. But this is now looking at a 2-digit times a 2-digit, which I think is a little bit more interesting to see how all of these things tie together. So what we have here is we have 40 and 5. So on this side of our rectangular array, we have 45. And we're going to multiply that times 23. So this is going to be our visual representation of this problem. So before we go any further, let's do our multiplication using the distributive property. So if we're multiplying 45 groups of 23, what we have is we have 40 plus 5 groups of 20 plus 3, which is going to give us 40 groups of 20 plus 40 groups of 3 plus 5 groups of 20 and 5 groups of 3. So now I just want you to notice that we have 4 partial products this time. We have 40 times 20, and here's our product to that. 40 times 3, and there's our product. 5 times 20, and 5 times 3. And those 4 partial products are going to show up when we do partial product multiplication. They're also going to show up in our rectangular array or our area model. And then I want us to lastly connect to our standard algorithm. So let's go to our area model. So if we're going to find the area of just this section right here, that's our 40 times 20 section. So the area would be 800, and of course that's the connection to this partial product. This is our 5 times 20 section of the area model, so that's our connection to that 100 partial product. This is our 40 times 3, which makes that connection with that 120 partial product, and of course our last one, 5 times 3, is 15 with that partial product. Now we should notice those appearing also when we do partial product multiplication. Remember, in partial product multiplication, we're multiplying by giving value to the places in their actual value. So 5 times 3 is 15. And now we'll multiply the 3 times the 40. And then we'll multiply the 20 times the 5. And we'll multiply the 20 times the 40. There's our final product. What's nice about partial product multiplication, and this is usually where students start, they make big connections here when they're learning multiplication of multi-digit problems between the area model or the visual representation and this partial product multiplication. So it's really fun when then students learn the standard algorithm and they're able to explain to you what's happening in the standard algorithm. So let's go ahead and do the standard algorithm. We start the same. We do 5 times 3 is 15, but remember the standard algorithm is going to combine a couple of these steps. So we're going to combine this 5 times 3 partial product and this 3 times 40 partial product into one sub-step. So 3 times, now we call it a 4 and not a 40, is 12 plus 1 is 13. And we know that 120 plus 15 is 135, so that shows up here. And then we're going to use a 0 to hold that place, or at least that's usually what we say, but essentially remember what we're doing is we're starting to now multiply in the tens place, so we want to shift all the numbers one to the left so that we can account for that. Because we're going to say 2 times 5 even though we know it's not a 2, it's a 20. So 2 times 5 is 10. Carry that one. 2 times 4 is 8 plus 1 is 9. That 900 shows up right here. If we add these two partial products, 100 plus 800, we get 900. So again, we're just combining those two steps into one for our total product. All right, I made it under 10 minutes. That was my goal. Stay safe, everybody. Thanks for doing a great job adjusting to this. We know that it takes a little bit of an adjustment and transition, but you guys are really rising to the occasion, and we just want you to know that we really appreciate that. Nice job.